My name is Paul Irish. I am a developer advocate on the Google Chrome team. I mean, talking about offline, talking about taking web applications that you make and making them work when you're offline and when you don't have connectivity. I think this is really important as we develop web applications, that we consider this use case of I don't have an internet connection. And the reason why is it goes back like 3 months ago. I was having brunch with an ex-girlfriend, and it was good. It was we were having some breakfast, and she's very smart, technically savvy, and she was telling me how she was going to create an app, and I was like, oh, that's cool. Like, what kind of app are you going to make? She's like, I'm going to make an iPhone app, and I was like, okay. It's fine. I'm just like, why? Why an iPhone app? She's like, well, you know, I want people to be able to use it when they're like on the subway or not connected. And I was like, you know, you could make a web app and it could do all those things. It could work when you're offline. And she just had no idea. And I was like, these APIs, all these HTML5 features are available. And she just didn't know. So I think that it's important that we consider this. It would make my ex-girlfriend make better decisions. All right. I'm going to talk about a few things. I'm going to talk about storing static content, storing content that changes, binary data, synchronizing that data back up to the server, and then increasing application performance. So kind of not even looking at offline, but how can we use some of these techniques to create better performance even when you're online? First though, taking a step back. This is kind of the landscape of storage before a lot of the HTML5 features that we have now. We had cookies. Cookies are delicious. They are. They're also useful when storing customized personal information for each user. Storage has been available inside Flash for a long time. Still is, but that's been used. Internet Explorer actually introduced the idea of a client-side storage mechanism. It's called user data, and I think it was back around IE5, IE6. So they beat everyone to the punch on that. Google introduced Google Gears 4 years ago, which had client-side storage. Dojo had a storage library that kind of was able to choose between all of these mechanisms. And the last one was window.name, which I really love. Raise your hand if you've used window name or you've looked into it. Okay, I'm just going to show this to you because I think this is really sweet. All right, I'm going to open up the DevTools. All right, window name. All right, yeah. So window.name right now is an empty string. It just stores strings. So I'm going to say, hola amigos. Good, cool. So now it's set to hola amigos. Now I can refresh the tab, and normally when you refresh a tab, you know, all the JavaScript variables that you've set are wiped out and reset, right? But in this case, window.name retains that. So yeah, you can actually store. So a lot of people have stored really large things in there, doing something like this, where they do JSON.stringify and pass it some big, huge object. And it stores like 32K. So anyways, it's kind of a neat hack. Of course, if you change tabs, it's not the same window, so it doesn't work. All right, anyways, we're going to move forward and talk about why this is important. There's a few ways I think that offline is very important, in addition to convincing my ex-girlfriend to make better decisions. The first of them is the oft-cited use case is you're on an airplane. I flew down here from California a few days ago, and I didn't have internet, and I do all my work in the browser. So having apps that work when I'm not connected is really important. You might be on a road trip in a car. You might be on a deserted island with a beautiful person, and you want to make them a dessert with all the coconuts that you find, And the only web app that you have that has your offline, your recipe database, to create that dessert, you would want offline access to that, right? I think so. You might have flaky connections, right? So connections that go in and out. You're on bad Wi-Fi at a cafe. You're trying to use your phone while you're riding the metro. Sometimes it's not just on or off, but it just is a bad connection. And then there's just ways of using these things to create a better, more responsive experience for your users. Lastly, I think the most important part is that when you can deliver an app that works when it's offline, it consolidates the idea that the user can always rely on it. It's a permanent app. The user knows that they can open it and work on it regardless of what their connectivity says, regardless of this guy up here and if he's enabled or not. They know that you can go in and use the app. All right, so we're going to talk about some HTML5 APIs that enable some of this stuff, talking about client-side storage first. All right, so the first thing is the app cache. Raise your hand if you've worked with the application cache before. Cool, good, yes. All right, so this is basically how it works. In your HTML, on your HTML tag, you set a manifest attribute and you point to a file. So this is just a text file. It's called myapp.appcache. And here's the content of it. So there's a few things in it. We start off with the words cache manifest. That's just how it starts off. Right here we have a comment, and it's just, it could say anything. In this case, we're just going to say version 1.0.0. It could be a timestamp of the last time I touched this file. And then we have 3 sections inside of it. And in each of these sections, cache, network, and fallback, we're listing out different files. All right, I'm going to explain these sections now. So the 3 sections are cache, network, and fallback. Cache is a whitelist of files that will go into the application cache. So the app cache is a separate cache. Normally, if you're delivering files and you put an expires header on it, or you put e-tags, last modified, it will go into the browser's disk cache. And the app cache is a separate cache. So when they're specified here, they go into that cache. Network is a little bit different. Network says, regardless of any other mechanisms, I want the resources that are listed here to be requested online. So this is normally going to be things that absolutely require online access, like you're accessing a third-party API. These can be references to your own URLs, or this could even point to another domain entirely. Fallback is kind of interesting, where you can substitute in a new file. So basically, here where I have 2 files. So this says, check to see if we're online and try and access index.html. If we're not online, just serve offline.html instead. And we'll just use that in its place. So it can kind of switch up which files depending on our online status. So what happens is the page loads, and then once, the first time that page loads, it reads through the file, it loads in all the HTML, it shows the page. At this point, it's like, oh, we have a manifest? Cool, I'll download it. It goes and it gets this file, downloads it, looks at it, sees what files are listed here, and if there's new stuff here, it's going to go and download those things. And then the next time the page loads, it's going to load it from the cache. And so it goes in this order, where anything listed inside the network section is going to be attempted to be requested. Then it's going to go into cache and load all those files that you've listed there and bring those up. It's going to go through the fallback section and first try and pull those down from the network. And if they fail, it's going to bring in the substituted in file. And lastly, you can have a wildcard in the network section where you could say, instead of login.html, I could have something like, let's see if I can do this, content editable. Could be something like API, yeah, something like that. Just deleting my markup as I go. Okay, cool, something like that. So you can have a wildcard in your network section, and just, it would pull in those things then. So it gets a little complicated. And there's a few gotchas too when you're dealing with the app cache. The first is that the page, the HTML page itself that is requesting that manifest, that will always be cached. So you could list it under the cache section, but you don't need to. It's just included by default. The next is, if the browser is going through the files that it needs to request, and it gets 1.404, it just cancels the whole thing. This is like, listen, I tried to get those files, I couldn't find one of them, I'm just gonna forget that you even wanted to do this, we're not gonna cache anything. And the same thing if you have a syntax error in the manifest file, it really doesn't like that, and it's gonna throw the whole thing away in that case. So it's smart to use a validator. This is a manifestvalidator.com, and so you can basically throw in your manifest here, and it will make sure not only that there's no syntax errors, but it will also request all the files and make sure that there's no 404s. To let the browser know that some of the files have been updated, so let's say I go back here, and I just updated background.ping. The browser doesn't know that I just changed it. So what we do is we take this version here and we just increment it. So it's 1.0.1, or we change the timestamp. And just by changing the manifest, the browser's like, okay, I'm gonna go and request all these files and get the latest ones. So that's kind of how we have to do that. Once the browser has grabbed the new files, it doesn't just substitute them in, the browser has to refresh the page. And that's a little tricky, and there's good ways to handle that. So a few of these gotchas and more are listed over on App Cache Facts. Some of the guys that worked at Twitter put together this page. Just has a nice summary of little tricky things when dealing with the app cache that are good to know. So one of the things that you want to do for sure is the manifest file itself. You don't want any server-side caching of that whatsoever, no expires headers. Because it defines another cache, you don't want it to be dependent on a different caching mechanism. It just gets really messy. The other is using the trick of showing a version number and just incrementing that as you go as a way to tell the browser, hey, these files have updated. You can add logging to the application cache. So in addition to the manifest, there is a window.application cache, there we go, object. And this guy has a bunch of events that he fires, and you can just bind to those and just add some logging so you get a better idea of when it's requesting the files. But I should point out that Google Chrome actually does a little bit of this for you. So I'm going to load up DevTools and bring up every time zone. Cool. Yeah, so every time zone tells us, well, in Rio it's 12:26, so it's 12:26 here. And we know that in San Francisco it's only 8:30 in the morning, but we can also kind of check out different times and see when the date changes. It's a nice, really nice app, and it works offline because they specified a manifest up here. But you can see down here, this is Chrome exposes this information, the login information, so it knows, it goes and grabs the manifest, it looks at it, and it starts to download all of them. And since it downloaded all of them successfully, no 404s, then the cache is cached and good. All right, and none of this works if you're testing this with a local file. Like like this, presentation, Chrome will just not have it work. You have to do it on like a localhost server, or just any HTTP protocol will enable application cache. So the trick is when you update the manifest and the browser is ready and it just got a brand new version, you can listen to that, right? And so you can bind to the update ready event on the application cache. And when that fires, you want to see, hey, did something in the manifest change? If so, we want to know about it. And so you could do something like this. So this asks the user. It just pops up a little prompt where we say, hey, we have new content. Would you like to refresh the page so that you can see the most recent stuff? So the Boston Globe actually just recently got a brand new redesign. And they use the same trick where on a mobile phone, they'll use the cache manifest and they will just prompt the user and have a little box that comes down from the top and be like, we have new content. Would you like to see the newest stuff? And you can do it that way. All right, so that's static content. That's files and that's the cache manifest. But we can also store dynamic stuff. And there's two ways that you would probably want to go about this. One is web storage, and the other is more structured client-side databases. So for web storage, that's the proper name for local storage and session storage. We're talking about storing unstructured data, miscellaneous strings, and it kind of replacing a lot of the times what we've been doing with cookies. But one of the nice things about web storage, an advantage, is that it doesn't have an overhead on HTTP requests. If you use a cookie, the value of your cookie is sent to the server on your HTTP requests. And so all your HTTP requests are larger. In local storage, it never goes back to the server. And so it means that your files are requested faster a little bit. Over in IndexedDB and WebSQL, client-side databases, storing structured data, and they both have support for transactions. So it's a little bit, whereas you might get into race conditions with web storage, IndexedDB and WebSQL are more safe when it comes to things like that. All right, so this is kind of the basic API for local storage. We're going to grab the local storage object and call the getItem method on it, and we're going to see if there's any check-ins that are already stored. If there's not any check-ins, then we're going to create some check-ins. So instead of getItem, we're going to use setItem. We're going to call it check-ins, and then we're going to put something in there. And we're going to put a string in there. In this case, it's an empty string. It's a string representing an empty array. The API for local storage is pretty easy. You can set items, you can get items, you can remove items, and you can clear them. Clearing clears all the local storage, but only the local storage for your origin. And so origin is the combination of protocol, domain, and port. So, I mean, it's basically your domain or your subdomain. And so clear is just clearing out all that stuff, nothing more than that. Session storage is very similar, but it's only for your session, of course. So the way that a session works, as far as this is concerned, is that the session lasts as long as the browser is open. So once you close the browser, of course, the session is gone. But if you open a page in a new tab or a new window, that's a new session. So your session storage will not be available over there. And so this is really good for just things that you want to keep around for a little bit. Like someone's filling out a form, and you just want to keep track of that as they go. You could store that in session storage. So one gotcha is that local storage and session storage only store strings. And so the way that we get around that is to use the JSON API. So this is what was codified from Doug Crockford's JSON2.js, and now it's available in all browsers. So we have native JSON. So what happens is we'll have something like this object here. And we just take that object and we pass it into JSON.stringify. And so that just creates, I'm just going to do it right here. That just creates a string, right, representing that object. So then we have it as a string. We can set it into local storage under user. And then when we're ready, we can just get it back out of local storage and send it through json.parse. And as a result, yeah, back to an object, and we're good to go. So it's common to just be doing that translation back and forth to strings using the JSON APIs with web storage. So a little demo of showing this off. So we have a text area, here, and I'm just going to type, my name is Paul, and I like ice cream a lot. So, this is really good. Okay, so if I just refresh this page, cool. Yeah, so the value inside the text area was retained, and we also know how long ago I entered the last content into there. So let me refresh that once more. Right, so 23 seconds ago. The code for this, like I just wrote a basic scratch pad where I'm just keeping track of whatever I typed in, useful, and it's like 5 lines of JavaScript basically. I grab the text area, on key up, I'm gonna do these 2 things, and I'm gonna grab the value, which is the text inside there, store that as value, grab the latest time, and just store that in there. And then on page load, I'm just going to get these items and populate that. So IndexedDB is for storing structured data. And so the way that it works is that you have object stores. They store objects. Inside the object store, you have an index. You can obtain a cursor, and you can iterate over the result set. So that's the vocabulary here. An index is just an index of any database table. It's a way of speeding up how you retrieve objects out of that. And so in IndexedDB's case, we're storing actual objects, right? You don't actually need to translate it into a string and then bring it back. You can just store a JavaScript object right in there. You can also open up a cursor, and that gives you an ability to iterate over the result set, checking the values of each object inside, instead of going key by key in the index. Yeah. So the status as far as browser implementation right now is that Chrome and Firefox have implemented IndexedDB, but all other major browser vendors are looking to support it, i.e. the Microsoft team just said that IE 10 will have support for IndexedDB. I know that Opera is also working on it, and it'll probably come to Safari at some point. But so right now it's available via vendor prefixes. So in Chrome, it's WebKit, IndexedDB, Mozilla, it's that. So you can just kind of alias them as the regular IndexedDB, just to make it a little easier to work with. The API looks a little bit like this. And it's a lot of asynchronous stuff. And if you've been doing work with either Node.js or even events in jQuery and JavaScript, asynchronous shouldn't be too scary. So we start off by grabbing IndexedDB, and we open a database. When the success event fires for that, then we're going to do some stuff. We're going to grab the database when that's ready. We're going to create a read-only transaction then. And then in that transaction, we're going to open up this object store and grab a cursor inside that. And then after that, on the success of that effort, we're going to do more stuff. So it's a lot of binding event listeners to each operation that you want to do. So let's see, I'm going to try, I think, drink Coke. No, okay. Create object store, yes. And Coke, good. Drink, better, Fernet and Coke. I know, right? It is. I love it. So I would recommend using something like LawnChair. LawnChair is a storage library that just creates a single API, and it can deal with multiple storage mechanisms. So it can deal with WebSQL, and it can deal with IndexedDB, and it can also store things in local storage and window.name. So nice API, and deal with the best storage mechanism in each browser on each device. All right, now we're storing binary data. Yeah, this stuff is cool. So when we're storing binary data, we're talking about the file system API. The file system API is pretty new. Pete LePage is going to be talking about this a little bit more in his talk later on today. This is the basic way that we start things off with the file system. Basically, we're dealing with files and folders on the hard drive. They're their own, it's a sandboxed area of files, so you can't be grabbing just any file off the hard drive, but we can create real files. So first thing that we're going to do is we're going to request access to the file system. We're going to say we only want this for a little bit, or alternatively, we can say it's persistent and we're just going to store things for a while. You request how much space that you want, so this is a megabyte of space. And then we have our success handler and our error handler. So if that succeeds, we're in our success handler here. We're going to start off by getting the root of the file system. And at that point, we're going to ask for a file. And we want logfile.txt. And if it's not already there, we're going to create it. So now we have a callback for that guy. And we're going to do this stuff. We have logfile.txt. It is our file entry here. And we got a few properties on it. We could say, are you a file? Mm-hmm. What's your name? Logfile.txt. What's your full path? / logfile.txt. Cool, cool. We could get the file object of it, which is a little different than the file entry, but it's a little difference. But the more interesting thing is that we can actually do operations on this file. We can remove it completely. We can move it into a new directory, make a copy, get the parent directory. So it's basically we have a JavaScript API for working with files and folders. So if I wanted to make a short little app, and what this app would do is I had these like images over here. I had like the what's his name? Kool-Aid Man and some other stuff, and I was just going to select these and drag them into my browser. And if I wanted these files to then be written into the file system API, this is what it would look like. So we start off by grabbing an element, and we're going to bind to the drop event. So this is HTML5 drag and drop. When things are dropped onto it, what we're going to do is we're going to grab the files. And so this stuff right here works in Firefox and Chrome, so we can just grab the files that were dropped. At this point, we're going to ask for access to the file system. We're going to grab a megabyte of space. And when it's ready, we're going to take these files, and the first thing that we're going to do is we're going to convert them to an array. Right now, they are a file list object, and we want them as a real array because we want to use for each. So this little magic right here just says I'm basically going to take that file list, change it into an array, and then I got for each. Then I got for each, I'm going to iterate over them and do this stuff. And for each one, I'm going to create a brand new file using the file name of each one. So it's going to be using the exact same file name of the file that I dropped in. And when I get that, I'm going to write a file. And that's how I do it. So I just call create writer on the file entry, and I write it to disk. And so, I don't know, 8 lines of code. And I can take anything that I drop into the browser and just write it into the file system. So I'm going to show you kind of how this works in action. This is HTML5 Rocks, which my team runs. We like to publish a lot of tutorials on how to do this bleeding edge stuff. And so here we're digging into these file system APIs. So this example down here. Okay, cool. We're going to add some files. So the files I just created, we did it using the same create writer methods that I was just showing. We have a log.txt, a my pictures folder, song.mp3, and I'm going to use this peephole extension. And yep, install. Cool. So peephole up here is just a way of seeing what files are currently stored with the file system API for this domain. So if it works, it should actually list out exactly what it says here. Yeah, good, cool. All right, so we see the log and see the my pictures. That's a directory. We can go back up, and if I open up log.txt, looks like the file is empty. But the interesting thing is this. So this is a file system URL. So the cool thing here is that it's a little weird. So it starts off with a file system, of course, and then it says what domain this is associated with, and then it says temporary or persistent, and then it says the file name. So it's pretty readable, but it's representing a file that's on my hard drive, actually. And this is just the way that we can access it. All right. So now there's 3 different kinds of URLs that refer to files. You're probably all familiar with data URLs. It's base64 encoded version of a file. There's also blob URLs. If you're dealing with the file API, you deal with blobs a lot. And the new file system URLs are pretty cool. So let's say that we had a file system URL like this. It's a myfile.ping. We can just set that as the source of an image and add that image to the DOM. And so that image inside this page is referencing the file in my file system, but it shows it just as normal. So it's pretty cool. So I can just integrate the things that are stored in file system into my page, and they work normally. Alternatively, if I have something like this file system URL, I might actually want to get that file so that I'm going to start to do some file operations on it. Maybe I'm going to move it. Maybe I'm going to delete it. So we use resolve local file system URL to do something like that. So then when we call that, we'll get a callback including the file entry object where we can start to manipulate it in the file system API space. Okay, cool. All right, so that's file system API. Exciting because finally it's the first way that we can deal with binary data and store it locally. This makes a lot of sense if you're working on an app and let's say like MP3s or even short video clips and you want to store them onto the computer. If you're not using binary data, then that means that you're going to have to serialize it to a string somehow, and it's going to be really slow. And so now having the ability to write real files to the hard drive is really exciting and makes this whole operation a lot faster. All right, so moving on towards data synchronization. If we're doing some of these things offline, we need to now tell the server, hey, we got new stuff going on. So there's a few ways of going about this, and here's a few techniques of synchronizing your server with your client. Using the fallback section inside your application cache manifest means that you can provide different files depending on whether you're online or offline. So you can kind of customize that experience and make sure that you're getting the right thing going in each case. Client-side templates are really, really useful in this case. So if you're using something like Mustache, Handlebars, jQuery templates, I mean, there's a lot of templating engines, but they work extremely well, especially in offline, because what that means is that you send down your data, and your data comes down as some AJAX request, comes down as JSON or XML, and then you just send it through your template. It creates your HTML. You throw that into the DOM, and you're good. At the same time, you can hold on to that data, store it locally, and then when you're offline, just pull it out of that store, shoot it through the templating library again, and then in the offline case, you can have the exact same markup based on the same data. So similarly, like I said, when you do any requests to the server, you're probably going to want to hold on to the data that it returns. So any AJAX requests, hold on to that because you're probably going to want that in the offline case. And then you can use, there's tricky ways to use iframes to update your application cache. So on your main page, you could open up an iframe, and inside that iframe is where you can do your work with setting up your manifest and using your application cache to preload some of those files so that you don't have that double load thing going on for your user. If you've used web workers before, there's also shared workers. And the cool thing with shared workers is that they work across tabs. So if I open up like a to-do list app in one tab, and then I open it up in another tab, and I start doing work on both, they can get really, really confused. So using a shared web worker means that both of those tabs can have the same worker beneath it, just talking to both and keeping track of what the story is. So this is really good and makes sure that your application doesn't get confused. So shared worker can be the one single thing that knows what the story is with the status. So you can just ask him, hey, are we online, are we offline? You can make sure that the data is consistent, of course, between the windows or the tabs of your app. And then also because you only have one shared worker that's kind of being that source of truth, it means that you don't have to run a lot of duplicate code across multiple tabs, and it can just be in one place, which can reduce the memory footprint a little bit and make things a touch faster. The Navigator online property and online events are how you know if you're online or offline, which is helpful. So navigator.online is either true or false, depending on what the story was. This was added to Chrome maybe 7 months ago, not too long ago, but other browsers have had it in place for a longer time. So this is good to go, good to use today. There's also events of online and offline, and these just fire when your connectivity changes. So I'm going to test this out. I'm online right now, and I'm not using Wi-Fi up here because I'm using Ethernet. So we'll try this. Yeah, sweet. Let's see. I can plug. Yeah, nice. So, yeah, okay, it works. Good. All right. So we've talked about the offline case of enabling apps to work when you're offline, but we can also tackle how to use these techniques even when you're online just for a better performance. So a few ideas. Using web storage in place of using cookies. Like I explained, there is an overhead with using cookies, and they're limited as far as the amount of storage that you can actually store. Web storage gives you a lot more capacity. Using client-side databases instead of asking the server for everything. So if you're writing like a messaging app and you go to the to fields and you're about to write an email to me, and so you start typing PAU, and you want to have like an autocomplete, you could go and ask the server, hey, I just typed PAU, do you have any autocomplete matches for me? Maybe you could let me know what that data is, and the server could respond to you. Alternatively, your address book or possible matches could have already been sent down to you. You could have cached it locally, and then as you type, you just immediately check the client-side database. It's a lot faster. There's no overhead on the wire, and there's no extra server load. So it's a lot faster that way. You can use app cache to cache assets for live sites. In addition for the offline use case, you can use it for live sites. And lastly, using the file system API is a really interesting way of just holding on to binary files that are large, and and you can even manipulate these files and kind of adjust them on the fly instead of always asking for the newest one from the server. So file system AI is still pretty new, but I'm excited to see kind of where we can take it. Inside Chrome, there's a few ways that we have to debug these features. The first is the Resources tab. So I'm just bring that up. So in Resources, we have kind of the assets that we're loading for this page, but down here, We have the MySQL, the web SQL databases, local storage and session storage, even the application cache. And so you can kind of see what's going on locally for these. We also have a few internal pages inside Chrome which show you some of these things. And the easiest way to get to these is going up to About. About shows you all the About pages, and this works in both Chrome and Firefox. So in Chrome's case, we have quite a few. Histograms is fun, because we have a lot of happy little charts and graphs. But in our case, app cache internals is really useful. So we can kind of, so this was every time zone, which I just showed a little bit ago. We can see the manifest, we can see the entries and see some stats about it. And the most important part is that we can remove it. So when you're doing work with the app cache, it's gonna cache more than you want it to, and you're gonna come back inside here and remove this again and again. As far as browser support, this is kind of the landscape right now. Local storage and session storage have been in IE since IE 8, so they're pretty good to go. IndexedDB, like I mentioned, is much newer, and so right now the support is only in Firefox and Chrome, but it's coming to other places. And app cache, IE 10, it'll be there as well. So that's kind of the story right now. Over on the mobile side of things, again, local storage and session storage, very reliable. IndexedDB is in Firefox Mobile, and app cache we have very good support for. It will not be in Windows 7, Windows Mobile 7 Phone Mango, or whatever that is. I get confused, but you know, at some point. Okay, cool. For storage capacity, quotas, in general, the story with Chrome in particular is 5 megabytes is the limit in most cases. And you can expect around that for most other browsers. But with a Chrome app, like if you're writing a Chrome app for the Chrome Web Store, you can ask for more storage and you can get it. And so you can store as much as you want, which is pretty cool. So this is the way, this is a brand new API, the quota API, for asking how much storage you're currently using and ask for more. So it's pretty cool. It works like this. We ask, hey, how much storage am I using? And you basically get this callback, and it says, this will say like 1 megabyte, and this will say 5 megabytes. And so you're like, I'm using 20% of my total storage. Alternatively, if at some point this comes back and it says that it's using 80%, and you're about to write another big file to the file system or something like that, you can say, hey, I'm going to need a little bit more quota. It's going to be persistent. It's going to stay there for a while. And I'm going to need 10 megabytes of it. And then it'll either ask the user or not, depending on which case, and then let you do whatever you want to do. So, like I mentioned, in a Chrome app, you can use as much storage as you want if you just set one little flag. And appmater.appspot.com is a really cool little quick website for, for creating an app out of a website in like 3 clicks. So you just come here, load this page, wait for the web fonts, and then you just say where your app is. And I'm like, it's at, HTML5rocks.com, and just fill out a few more things, and then you're basically good to go. And it helps you set up adding it to the Chrome Web Store, so you can get that in the Chrome Web Store in under 5 minutes. You only need to ask for this unlimited storage permission if you want that storage, and it looks like this. So this is the manifest for a Chrome app, just a bunch of JSON, and here I just ask for unlimited storage permission. The user says, when they're installing it, it'll be like, this app wants to use your hard drive a bunch, and they'll be like, sounds good, cool. If you create an app and it works offline, I would encourage you to say this. offline enabled is true. And what this means is that on the new tab page, when these apps are here, if you're offline, all of them will go to like gray. There will be no color except for the ones that said that they're offline enabled. So that's how your users will know that they can still use your app even though they're not connected. All right, we just launched offline Gmail not too long ago, maybe 2 weeks ago. Raise your hand if you've used offline Gmail so far. Yeah, cool. I love this. All right, I'm gonna show it off right now. Let's see, I want to open it in this browser. Cool. All right, Chrome Web Store, offline Gmail. I already have it installed, so I just launch it from here. Yeah, cool. All right, so this is offline Gmail. We're looking at my email right now. It looks like, yeah, there's some stuff coming in from GitHub, some issues, I guess. But so it's a tablet. Right now it's a tablet UI. So it's a little bit different, but the cool thing is that it works when I'm offline. And so if I hit refresh, you can see this little guy down here updated. Oh, and I got new mail. Hello. Oh, I joined a group on LinkedIn. Awesome. It's cool when you go offline and then you come back online and then this is like synchronizing, like 90% done, and it just tells you, and you can do all the exact same things, write and reply and archive and delete and label, and it works just the same. And I could tell, like, on the flight down here, it was a long flight, I loved being able to just work on this email, so it was very exciting to have that. All right, I'm back. Whoop, excuse me. Okay, good. Cool. The last thing I wanted to show is a few polyfills. Polyfills are basically small JavaScript libraries that just add a feature if that feature didn't exist. So like I mentioned, there's no local storage or session storage in IE7 or IE6. But people have written, the community has just written a lot of scripts to add these features when they're not there. So Remy Sharp and Andrea Giamarchi have written small libraries that add it. Storage.js is another good one, and if you use YUI, there's a great offline caching library for that. Stash is even another one, and Lawnchair, like I mentioned before, is great for normalizing between WebSQL and IndexedDB and a few others. Also, if you're interested in digging more into binary data in the file system API, one of my colleagues on the Chrome team just wrote this book from O'Reilly about that. Small book, but really good. And that's about it for me. So I'd love to answer any questions if I could right now. Sure. So the question was, how do these storage mechanisms affect events like onload and DOM content loaded, the DOM ready event? So I can tell you for the application cache, for instance, right? So the application cache is the page loads, and after the page is done loading, the browser then reads the manifest and then sees what's in it and downloads the files. But the window.load event has already fired. So the browser knows that that should be a lower priority, and so it tries to do all the things that are important to the page loading first and takes care of the rest later. Anything like if you were doing local storage or IndexedDB lookups as the page is loading, that means that window.load would take longer to fire because it's sequential. So you would hold up those events a little bit. Sir? Sure. So the question was, IndexedDB on Android. I don't know is my answer. There's been a few, some exciting news talking about WebKit and Android and them working together a little bit more recently, and I'm really excited about that. And so Ice Cream Sandwich is coming up, and maybe we'll see something there, but I don't know for sure if we'll be seeing IndexedDB just yet. I hope so. I can also point out that the IndexedDB work happened at the WebKit level, and so other mobile WebKit ports have access to that if they're interested in doing that, so iOS or Palm or any of the other ones. All right. Cool. I guess we're good. Thank you guys very much. I appreciate it.